Hello, this is my AP Calculus AB project. This is my function r of x, and this is how r of x is graphed. And so, does r of x fit all 6 criteria? The first criteria being that the numerator and denominator, which is f of x and g of x, are both polynomials, and they are. The second is that f of x and g of x should have either 2 or 3 roots, and they both have 2. Number 3 is that r of x should have at least 1 root, and equaling the numerator to 0, x is equal to 1, which is 1 root. 4 is r of x should have at least 1 vertical asymptote, and so equaling the denominator to 0, we could get that the vertical asymptote is at x is equal to -3. And for a horizontal asymptote as its end behavior, you could see here the end behavior is equal to y is equal to 1. And looking at the leading degrees and leading coefficients, which is 1. Now for a close-up, and for its hidden behavior, which is at x is equal to 2, so that's where it's undefined, we could see that on this graph, the vertical asymptote is at x is equal to 3, and that the horizontal asymptote is y is equal to 1. So these are all its characteristics and quirks. The limits of the discontinuities at x is equal to 3 and x is equal to 2, as limit of x approaching 2 of r of x is 1 over 5. And as the limit of x approaches -3, the denominator would equal to 0. So this means that we have to check both sides, and using for the negative side -3.001 and for the positive side -2.999, as the limit of x is approaching -3 to the negative from the negative side, it's positive infinity, and from the positive side, it's negative infinity. The ends behavior, looking at the leading degrees, which are both equal to each other, so this means we look at the leading coefficients, which are both 1. So that means that the function's graph approaches positive infinity, infinitely to the right, and negative infinity, which is infinitely to the left, on y is equal to 1. And so, next, for the continuity and discontinuity, we have the original graph and we have the simplified version of this graph. And we already talked about how x is equal to 2 and x is equal to -3 are discontinuities, but putting a name on it, x is equal to 2 is a removable discontinuity, and x is equal to -3 is an infinite discontinuity. And its domain is negative infinity to -3 union -3 to 2 union 2 to positive infinity is where it's continuous. Derivatives, with using the simplified version of r of x, finding r prime, we use the quotient rule, which is seen right here, and we get 4 over x plus 3 cubed. And for r prime of x, I use the chain rule combined with the power rule to get r double prime x is equal to -8 over x plus 3 cubed. And so for the complete analysis, I have to get the y-intercept and the x-intercept. To find the y-intercept, I equal x is equal to 0, which gave me the y-intercept of -1 over 3, and for x-intercept, equaling r of x equal to 0, which gave me the x-intercept of 1. For the critical points, I equaled r prime to 0, and because there is no solution, means that there is no critical points, and also equaling the denominator to 0, that simply gives us the vertical asymptote, and it's not a extrema. Now for increasing and decreasing, looking at r prime, both numerator and denominator are both positive, so that means r prime is greater than 0. So getting the values of -4 and 0, which is just random values I chose, they're both increasing on negative infinity to 3 and -3 to infinity. Continuation of the complete analysis, looking at the concavity and the point of inflection, looking at r double prime and equaling that to 0, there's no solution, and even equaling the denominator to 0 again, I get the vertical asymptote, which is not the point of inflection, so that means there's no point of inflection. And so now looking for the concavity, r double prime of x, I again use the values of -4 and 0 to get that it concaves up at negative infinity to -3 and concaves down from -3 to positive infinity. For MVT, it has to be continuous, which it is on 0, 1, and it is differentiable on 0, 1. MVT applies. And so the first, we calculate the average rate of change, which is the secant slope. We input 0 for A and 1 for B, which we get 1 over 3. Then we get the first derivative and equal that to 1 over 3. We cross multiply and we get the square root of both sides to solve for c. So the interval of 0, 1, r of x increases by 1 over 3 for every 1 unit. The slope of the secant line between the points of 0, 3 is 1 over 3. As for the instantaneous rate of change, the value of c, which is this one right here, not this one, because it's not in the interval, but tangent is exactly equal to the average slope of 1 over 3. And so for this picture, the red curve is r of x, while the green line is the secant line, and the blue line is the tangent line. Now for the intermediate value theorem, making sure that the interval is continuous on 0, 1.5, and I chose the root x is equal to 1. It is continuous, and IVT has 2 conditions, which it does fulfill. And IVT states that since the function goes from negative y value to a positive y value continuously, it has to cross the x value at some point. So because these are both met, IVT guarantees that root x is equal to 1 exists on this interval. Extreme value theorem, I chose the domain 0, 3. And it states that as long as the function is continuous on a closed interval, it must have both an absolute max and a minimum value on that interval. So that x equals 2, the discontinuity is removable. This ultimately doesn't stop me from being able to find the maximum and the minimum. So the absolute minimum being 0, -1 over 3, and the absolute maximum being 3, 1 over 3. The tangent line and normal line I had to select a point that is not a minimum, a maximum, or a discontinuity point on r of x. So I used x is equal to 0, and I inputted that to the original simplified equation to find the y value, which is negative 1 over 3. So I inputted the x into r prime to get the slope, and once I got the slope for the tangent line, I put this into slope-intercept form, which is y equal mx plus b, and I got this equation. Now for the normal line, I got the slope for the tangent line, and I got the negative reciprocal of it to get negative 9 over 4, and I input that into a point slope form, which is why it looks different to the tangent line. And so I made the sketch of how this would look like with r of x, the tangent line, and the secant line.